Hey everybody, this is Larry. This is day 15 of the February Legal Day Challenge. Hit the like button, hit the subscribe button. Did I not do this? Oh no, this is just today. Okay. So we'll do the premium prom, the weekly prom after this as well. But hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's prom. Yeah. And at least in New York, it's still Valentine's Day, so happy Valentine's Day. Hope you're spending time with people you love or whom loves you. Or whatever, however you want to spend your time is fine. Or you could spend it with Larry and Leetcode. So I don't know, it's up to you. Today's farm is 2971. That sounds like something we've done recently on a contest, but yeah, find Polygon with the largest parameter. Okay, a Polygon. Okay, yeah, this one I remember a little bit. I remember struggling with the contest, and trying to do proofs on the contest. But the idea here is kind of a sort of greedy and induction, right? The idea here is that, okay, well, so you have this formula, right? You have this this formula here, yeah, where you have basically what is it? Whatever, right? So A1 plus A2 plus A3 plus A4 is, I don't know, I'm just gonna stop at 5 for a second. Is equal to A5, right? And then now, if this is the case, then now we see if there's an A5 where that's the case. And the reason why this is the case is because now we know that this is a polygon. But also the other thing is that in a greedy kind of way, you wouldn't if you eliminate any number to the left, it would only make the sum smaller. So it would only make this less possible, right? So in that way, it's kind of almost like a greedy. I mean, it is a greedy, but it's almost like not quite a proof by contradiction, but just that like anything else doesn't really make sense. And then now, and then and maybe another way to phrase it is just that, let's say you have some number A10, right? Well, we want numbers that are, given this other condition of smaller or equal to, run numbers that are smaller to it. And then in a greedy kind of way, as we said, we'll have just A1, A2, A3, all of them, right? So that's basically the idea. And I remember this one during the contest, I just kind of, for some reason, like I think I was too, during the contest, I was too stuck on thinking about triangles. Because, for a triangle, then this is the triangle inequality, and I think there are just like a lot of baggages, if you will, from years of experience. But for some reason, I just kind of wasn't able to generalize, which happens sometimes when you get stuck. I mean, if I know why I get stuck, then I wouldn't get stuck. So it happens from time to time. But the idea here is just take a greedy and you can do it. So how do you do it, right? So yeah, I mean, I think the sorting makes it n log n anyway, so everything's gonna be n log n. So then we could just kind of walk the thing. The interesting thing is, of course, if yeah, I mean, so basically so we have to do is go to num sub 0 plus num sub 1, right? Something like that. The first two number. And then for I in range from 2 to n, right? If current is greater than num sub I, then maybe we can do, what are we returning to? Oh, the perimeter, right? So, okay, so this is fine. So then now, then we can add it to the current perimeter, and that's pretty much it. I think this is all, and then we just return current. Obviously, given that this only increases, so this, and in a backwards way, this is basically how you do like the sum of all. This is, you can think about current as a prefix sum in another way, and this is basically the sum of all numbers prior to this index, and whether this is bigger. If it is, then you can add it to the possible polygon, and then you test for the next number. It kind of does like a few things at the same time, which is a little bit confusing looking. Did I mess up one? Huh. I guess I didn't consider this case. Sorry. But yeah, but the idea is still right. I just thought that you could do it with an induction kind of way. So maybe the induction thing isn't quite true, as you can see here. But but it's still that for given I, you can try to do all the previous ones, right? So here, maybe current is so if current is bigger than I, then best is equal to max, best current plus num sub I, right? And yeah. Oh, and I didn't even do the -1 case. I think that's also a thing, right? I guess I could just have done this as set as -1 as a default sentinel. Yeah, so now we give it submit. That's pretty much it. Like I said, during the contest, I struggled a bit with it. This is going to be linear time. Oh, sorry. Well, this part is going to be linear time, constant space. But of course, we have to do the sorting. So it's going to be n log n time, linear space. Yeah, and apparently this is only for like 2 months ago. So it wasn't even that long ago. And I actually mostly wrote the same code, it seems like, during the contest. Even though I remember it took me a long time for Q2, maybe? I don't remember. But yeah. I think the key part about this one is, key observation is just that it is a greedy, and noticing that for a given K, or given I, just take greedily, take all the numbers smaller than it as the sum, and you'll be fine. I think that's the part that for some reason I got stuck on that proof about, like, I was like, oh, is there a scenario where you could take, like, I don't know, 3 of the small size but not the 4th one? And then at some point because I think in my head I phrased it in a weird way, and that's where, if you have enough practice and enough flexibility, you could phrase things in a different way. And once you rephrase things in a way that you can understand and then improve immediately, then it just becomes easy. And for me, like I said, the way that I think is the clearest is just that, given some num sub I, sum up all the numbers before or smaller than it, right? And of course, if you don't do it sloppily, you can do it n squared, but just to give you an idea. And then with experience, you jump to the prefix sum looping to kind of handle that, right? So yeah, that's all I have for this one. Let me know what you think. And yeah, I'll do the premium weekly problem after this. So stay tuned and stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.